Okay, so we're continuing problem 1. We're doing number 6 on problem 1. And remember, we just kind of converted our formula so that we can start with a C and move to an F and make that easier. So here, problem number 6 says the hottest temperature ever recorded on Earth occurred in Africa in 1922. It was recorded in 57.8 degrees Celsius. Use your new formula to determine the temperature in degrees Fahrenheit. So I'm going to take this, I'm going to put it in for C. So 9/5 times 57.8 plus 32 equals F. Now see how it's much easier. We did all the hard work up here, and now it's much easier to do the work from here. So again, just now my calculator, I'm going to hit alpha y equals to get my fraction. 9/5 times 57.8 plus 32. So Fahrenheit, my Fahrenheit is 136.04 degrees Fahrenheit. So those two are the same. All right. And number 7, dry ice melts at negative 78 degrees Celsius. What temperature is that in Fahrenheit? So again, you're just doing the same thing. So this one you do on your own. You should be able to do this problem on your own. So number 8, Carlos and Michaela did not like working with fractions. We were working with fractions. So they write their equation so it doesn't have fractions. And this is what they do. Okay? Notice, remember, the main rule we're working with is that whatever you do to one side, you can do to the other. As long as you do it to the other, you can do that to an equation to make it look the way you want it to. So here, Carlos multiplies the original equation that we made, right? The 9/5 C plus 32. He multiplies it times 5 on this side and times 5 on that side. And as long as what you do to one side, you do to the other, it's okay. So he ends up with 5F here. He multiplies by 5 here, and he distributes. 5 times 9/5, the 5's cancel, right? So that's leaving 9C, and then 5 times 32 leaves 160. And now he takes this and he rewrites it. And what you don't see that he really did here is he subtracted 9C on this side, and he subtracted 9C on that side. That left 5F minus 9C here. And then these two canceled on the right side, leaving 160 on the right side. So it looks like his work's pretty good. Now, Michaela started with the original, not the formula we came up with, but the original that converts Fahrenheit to Celsius. But notice her idea is the same. She multiplies by 9 on both sides. And when she multiplies by 9 on both sides, as long as what you do to one side, you do to the other, it's okay. And she chose 9 here because 9 was the denominator of the fraction. Carlos chose 5 because 5 was the denominator. So that leaves 9C on the left side. And then here, she multiplies 9 times 5/9, and those two cancel. That just makes that a 5, right? The next step, she distributes the 5. So that leaves 5F minus, and 5 times 32 is 160. And then again, she takes things to the other side, and her step that she doesn't show is she's subtracting 5F from both sides, right? So by subtracting 5F on the left side, she gets 9C minus 5F. And by subtracting on the right side, these two cancel, leaving negative 160. Now, Carlos has a different equation from Michaela, and they want to know who is correct. And the point is, both are correct. This whole project is to show you that there are several different ways to represent the same equation. And as long as your algebra is correct, you can manipulate the equations to look the way you need them to look. These two are equivalent. And the only difference is this one is the opposite of that. If signs. So if you take the opposite of 5F, you get negative 5F. You take the opposite of negative 9C, you get positive 9C. You take the opposite of 160, you get negative 160. So taking the opposite of both these sides will give you this. That's how you know. Because again, if you do what you do to one side, you do to the other, then that means they're equivalent. So both are correct. So you need to write your own explanation. They both are correct. Both have correct math. They're just opposites from each other. Now, in the original equations, the coefficients 9/5 and 5/9, as well as the constant 32, had meaning based on temperature. So the original equations, right, like F equals 9/5 C plus 32, right? We're talking about slope and y-intercept here, right? 32 was the starting point. That's the y-intercept. And it means when C is 0, then Fahrenheit is 32. And we all know that. Like freezing point is Celsius equals 0, and it's also freezing point for Fahrenheit is 32. So that's what the 32 means. When Celsius is 0, Fahrenheit is 32. And the 9/5, we all know slope is a rate of change, right? For every 9 degrees that you go up in Fahrenheit, you only change 5 degrees in Celsius, right? So the slope has a meaning here. The y-intercept has a meaning. But now we're looking at Carlos and Michaela's equation. And we've got 5F minus 9C equals 160 for Carlos's. Let's just look at his. Now, we've got 9 and 5 as a constant and 160. And they're wondering if these have any meaning. What do they mean? And the one thing that they're trying to get at here is that they don't honestly have meaning with respect to these equations. So sometimes forms are useful, like Carlos and Michaela found this form a useful form of the equation because it didn't have fractions, but sometimes you lose meaning when you look at it a different way. Sometimes you gain meaning when you look at it in this way. This is slope-intercept form, and these numbers have meaning for slope-intercept form.